Okay, third video for the division algorithm section. So the second video on division algorithm. And I'm going to do an example, and then the next video I'll do a more complicated example. This is a simpler one because I'm dividing by a binomial, and because both the numerator and the denominator, the powers of x go down 1 each time as you go left to right, right? So it's a square, then there's a single x, and then there's no x's, no factors of x. 2 factors of x, 1, none. 1 factor of x, none, right? And you want to write them in this order. If you don't write them in this order, then this algorithm won't work. For highest power to lowest power, highest power to lowest power. If you don't do that and you can't get it to work, well, that's normal. It won't work. So this is how the problems are going to be stated. Use the division algorithm to write this thing this way. So remember, that's just going from like a improper fraction to a mixed fraction. So it means just do long division. Okay, so you have to know what that means, especially like on a final exam. You have to remember what the heck do they mean there. They just mean do long division. That'll be your quotient, the thing on top, and then the remainder over the divisor. Okay, so let's try this. So first you write it out that way. The dividend, that is the numerator from the original, goes inside, and then the denominator goes outside. And then what you do, instead of saying, okay, what do I multiply this by to get this, or a little bit less than this, instead of doing that complicated thing, you just take the first term here and divide it by the first term here, and you put that there. Even if there's a fraction involved, you know, like a fraction of coefficients, you just take this one over that one, even if there's a negative, right? That one over that one. So it's x. And I would write it over here. Why over here? You want your x squares, your x's, and your constants to all line up like this. It's just the easiest way to keep track of it. There's other ways to write them down that you'll see sometimes, but I think this is the best way. So you'd put the x over here just because you put an x over the x term. Okay, so x squared over x is x, and that x goes here. Okay, right there. So I even wrote where it came from. And they're colored so you can tell which x is which x. Okay. Now I have to take this x and multiply it by both of these. What I used so far is I didn't use the 2 yet, right? I just used the x squared and the x. I need to use the 2. So I'm going to take this x and distribute it across these two. The first one gives me the x squared, of course. And the second one gives me 2x. Okay, so that's what I did there. Then I have to subtract. Now, when you're doing this with integers, we usually don't write the minus sign, but that's because the integers that we're doing it with are always positive. Here, your polynomials can have negative signs. It's no problem. You can have negative coefficients. So we have to write the minus sign in. And you have to subtract both terms. So you need parentheses. Okay? Don't go in and change the sign of each of them. I know a lot of people do that. Some people even teach it that way. That's really bad for several reasons, but the number one reason is because more people get them wrong, and that's always a good reason not to do something. If the percentage of successful, people who are successful doing something a particular way is lower than some other way, then you do it the other way. You do it the way that the largest number of people get it correct, and this is the way the largest number of people get it correct. So what you're doing, you do have to be careful with signs, of course. A number minus itself is 0, so you just don't write anything there. This first one should always be, these should be identical, and you're subtracting them. Oh, the second reason that you don't just change the sign and change the sign, like actually write down the distribution of this minus, Don't write that down. The second reason is because then when you go back, if you make a mistake and you go back to look for your mistake, you can't find it because you changed these things. Or maybe you change them back and you change them again, and then you get lost. How many times did I change this thing? And you just scratch it and start all over again. It's a waste of energy. So I would do this. And if you can't distribute a minus, I feel sorry for you. Okay? It's minus this, that's 0. This is a negative 2x. So negative 3x, negative 2x is negative 5x. So be careful of that. In fact, do that like twice when you do that subtraction one. Look at it again, minus negative 5x. Okay? Now, I have 2 terms here, and so just like this, I'll need 2 terms down here. So I bring down my 1. Just like you would with long division of integers. Now I take my minus 5x and divide it by x, and I put that here, and you'll see it's a constant, so it lines up with these constants. Minus 5x over x is minus 5, so I'd write minus 5 here. Okay, I'm showing you where I got that from. Okay, now I have to, again, so I'm just repeating this thing. That's what algorithm is, kind of repetitive procedure. So I've got this minus 5 here. Now I take the minus 5 times both of these and write it below here. Right, so minus 5 times x is minus 5x. These are identical, not opposite signs, identical, so I know it's right. Minus 5 times 2 is minus 10. Okay. You have to distribute that negative 5. Negative 5 times x, negative 5 times 2. And now you're going to subtract. Even though there's already minuses there, you still always have to put parentheses and subtract. Always. So you have minus 5x, a number minus itself is 0. And then the second one, you're actually adding 10, right? The opposite of negative 10 is 10. You're adding, right? It's a product, right? So you get 10 plus 1 is 11. See, there's a lot of little arithmetic things here, but this is like one of the best exercises that we have in this course for working on your arithmetic. I mean, just basic arithmetic with multiplying integers and stuff and subtracting. Double negatives, things like that. So that's my answer. They wanted it in that form. It says right here, right? What form they want it in. So the quotient is x minus 5. So that's my, I think of that like my polynomial part when you do this division. Right? Plus the remainder, 11, over the original denominator, which was x plus 2. Right? X plus 2. So the divisor always goes on the bottom, not the dividend. Divisor. So this should be the same as the original. Right? And that's it. So the next one is a little bit more of a complication, and it's a bit longer, and I didn't write in all these little things like this. So if you forget what's going on with these things, you have to go back to this example. Get this one down. In fact, I would get to where you can do this problem without looking at it, this specific problem, without looking at this stuff. And just keep going through it until you can do it without looking at this stuff, but understanding each step, not just memorizing the things here, but understanding each step. And then get to where you can do that without looking at anything. Then do a bunch of ones that are like this. And then branch out to the ones that are harder that I'll do next. They're not really a lot harder, but they're a little bit trickier.